Our next example is to show you how recurrence relations are related to algorithms. So again, as an example, so here example, write a Java code to find the summation of, this is the summation, I'm going to call it S, okay, S, there is no need now to call it S, just to find the summation that starts from 1 up to n of I. So this is our question. So we will write the code in Java. So it will be a loop, integer, where we put a variable sum equal to 0, and we write a for loop, a very simple for loop that starts from 1 up to or equal to n, I plus a plus, and then inside we write sum equal sum plus 1. So it's a very simple program, very simple code that it finds the summation from 1 to n. If we ask you to find the running time of this algorithm using growth functions, then this is a linear because the loop goes from 1 to n, so it will be big O of n. Now, how to describe this summation in as a recurrence relation? If we look at the variable sum, okay, notice it is a start number is 0. So let me call this sequence S. So we will write S, this is the beginning, okay. So as a recurrence relation, we will write, I will just write a title for that, okay, recurrence relation. We would like to describe this code as follows. I will label the variable S, or the recurrence relation S. So the first value of S is 0. So we will have S0 is equal to 0. And this is coming from here. Now for any subsequent number, so here this subsequent number, so here I will put a label so that you can remember. This is the old value, or we say the previous value, and probably it's better if I call it the previous value, predecessor, previous value, and this is the new value. So to get the new value, we get it from the previous value plus 1. How we describe this by a recurrence relation? We say if we want to know the sum at n, so the loop goes up to n, maybe I can call it I. Then it is the previous value plus 1. And this will start for n from 1, and this is why we write the loop that starts from 1. So this is the recurrence relation that we found from this code. If I want to write the summation as a recursive function, so here we will write this code as a recursive function, okay? Recursive function or method, okay? Recursive function, in Java it is called method. Then it is very simple to implement it. We will define the name of the method and we will call it sum, and it has the input parameter n. Now you know that for recursion, eventually the recursive call will terminate at a termination condition, and this termination condition is here. So we write if n equal 0, then return 0. Otherwise, we will call the method sum n minus 1 plus 1, and we will call it recursively. So it is a copy just exactly the definition you have found for the, or the description you have found for the recurrence relation. You can implement it directly. So what is the relationship between, why we are interested, okay, to convert into sequence? Because there are some recursive functions. If this recursive function is described using this recurrence relation, we are so interested to know the timing, the running time of this algorithm. So you need to convert it into its solution, and you know that its solution will be expressed in terms of n, and then from the solution we can say what is the growth function, or the or what is the big O of this algorithm. So basically this is why we are interested for recurrence relations, that if we have a recurrence relation we need to find its solution.